Okay, hi everybody. My name is Andrey Kudryavtsev. So I have to manage several things at the same time, record myself as well. If I didn't give you a sticker, please stop by. I'll give you a sticker for DAOS. If you are presenting here, make sure you send me your slides after that. So with that, let's continue. So as I said, my name is Andrey Kudryavtsev. We moved to the HPE session, so I call it for the future of storage supercomputing. And the reason here is to get you familiar with what HPE is specifically doing around the DAOS-based solutions, how we define it in our portfolio of different storage products, and where we see that continuing forward. So, as you know, short introduction, since the last year, the whole DAOS development transition from Intel to HPE, I joined HPE in February this year, and I'm a product manager of the solution which based on DAOS. The code name of that solution is K3000. I'll tell you the long name later. But it comes into the whole portfolio of the storage products that we have. And we have the our traditional historical products based on the Lustre cluster store family that continues, and it's moving forward with the development. And the DAOS team and DAOS development team joined with the same engineering organization as we have a cluster store. Within this organization, for DAOS specifically, the team that transitioned from Intel continues to operate unchanged. That's why you don't see any changes on the foundation roadmap, and continue developing as it was in the past. Plus, we have our development for our own DAOS-based solution, and that comes with additional resources. So that's a great part of that we are able to even put more investment into the development of these and continue doing what is happening in the open source domain, the foundation. So the full name of the product is HP Cray Supercomputing Storage System K3000. So for short, let's call it K3000. The reason for that, why it's K and why it's 3000, because the Lustre solution is E3000. I'm sorry, E2000. So many names in the currents. Basically, that continues the same terminology of these. And this slide I presented at IC earlier this year at the DAOS virtual group. And basically, we are approaching the design that we presented as the reference architecture originally. So expected that reference architecture became our full production architecture. What this system consists of, and what are the difference from the typical, I would say, DAOS foundation deployment with the HP solution. Well, first of all, we are introducing the definition of the admin management node. That's not part of the DAOS. So in the DAOS foundation installation, you don't need this. In HP systems, you do, and it's not sitting anywhere in the I/O path. However, it's managing all the provisioning, telemetry, orchestration of the storage nodes underneath. And the storage nodes are specifically based around our ProLiant family, so that's a DL360 Gen 12. That's the latest generation of the Intel Granite Rapids SP platform. It's a dual socket platform and design, and this platform has a really nice capabilities to provide a very rich I/O systems. So in particular, we are using the configuration of this platform with up to 20 E3.S and NVMe SSDs. So all of them running on PCIe Gen 5 speed. All of them front-loaded, and it's a quite dense system. So we've providing the three capacity options for the NVMe SSDs. So we have basically 384, 768, and 1536 terabyte NVMe options. We can go up to 300 terabyte in 1U. So that's the highest density that we can achieve today with this class of products. And in order to support up to 300 terabyte in 1U, obviously we have to combine it with the DRAM match. And the DRAM capacity for these systems are, actually there are four. So starting from a 256 up to 2 terabyte of the total capacity of a DRAM that we are using for the largest density of the system with 300 terabyte. Every system provides 2 PCIe slots for the fabrics, and we support pretty much everything that exists today. Of course, that's coming with the own Slingshot products, own HP products, Slingshot 200 and Slingshot 400. And later this week, Michael Haneke will be presenting the performance on the Slingshot 400 for the first time publicly. That's great. That's coming from internal development. Absolutely, lots of the focus and attention to the Connectix 7, the InfiniBand, and the Connectix 7 in the Ethernet mode, so support for both. And that provides us a really nice coverage for the different types of the solutions that HP is targeting for. On the system configuration side, and now we're going really deeply into the SKU stack and the SKU configurations, we base the platform around, let's call it 4 base SKUs, defining it by the number of the NVMe SSDs the platform comes configured with. I already said that it goes up to 20 NVMe drive slots. We pick options at the configuration to limit users to set it to the 8, 12, 16, and 20. And the reason for that, obviously, you go with 8, that is the minimum number of SSDs to put into the line rate and optimize it for the whole line rate for read performance. And then with the 12, 16, and 20, you go upper to increase the capacity and increase the performance. Obviously, that provides us a lot of flexibility on how we address the customer requirements when it comes to, let's say, oh, give me 1 petabyte of a solution. So at what performance you need 1 petabyte? And then we can size the system appropriately. We have different sizing options to this. And that's internally, obviously, we have the tools that helps you in sizing these calculators and helper tools that will provide you the full BOM and the full configuration. But based on this type of a design, first of all, we are using and reusing the same platform across all of these configurations. It's just configured differently. For the less number of NVMe SSDs, it doesn't come with drive sleds, it comes with drive blanks, and so that also helps to optimize the BOM and the system configuration. Where we see that forward, of course, expanding these to support more hardware, and I will talk about that a little later. Go ahead. I will stop.
Can you explain why you went for dual socket rather than single socket?
Absolutely, I can. So we, as the HP, very rich portfolio of storage of servers that, of course, they can be optimized for the storage use cases and storage applications. And for quite a long time, actually, internally we debated: should we go with a 1-socket platform or should we go with a 2-socket platform? And for the 1-socket platform, we have great solution. It's called DL'25. It's also based on a Grand Rapids SP. We seriously consider that to be the platform of choice. However, you have to think in mind that if you go with a single socket, in order to provide the up to 20 NVMe unblocking configuration, and in order to support 2 fabric interfaces, we had to go to very specific SKUs of a Grand Rapids called rich IO SKUs. So, you start limiting yourself what type of CPUs you can use. That's the first. And then you also have to increase the TDP of the CPU. So when you compare the 2 sockets of a lower TDP and a single socket at the much higher TDP, you have a different power and cooling requirements. And for us, in order to support that many cores on that specific rich IO SKU, we have to use the closed-loop cooling, liquid closed-loop cooling inside the system. And then you move to this. That puts implications on the serviceability of a platform. And as we know that storage can run more than 5 years, we wanted to make sure that it's simpler to service and it's more convenient to service the full platform itself. So the real motivation here was from the serviceability perspective. Single socket platform is a great design, by the way. Go ahead.
Why those 3 sizes of SSD?
Why we have 3 sizes of SSDs? So we certainly need the smallest size of SSD to address some installations where we really target to optimize it to the performance, because you need to get to the quantity of SSDs in order to get aggregated bandwidth and aggregated IOPS to deliver. And that's just think about that like a 2D vector, how we provide the whole platform configuration. We have the drive count per system, and we have a capacity of NVMe SSD. So when it comes to the requirements for the certain capacity, we have options how we basically designed the platform to make it more efficient. Efficiency and the performance, that's the main idea why we have these three options. Question is why we don't have a fourth option for the even higher capacity, and that's coming later.
One question on the S3 gateway. Are you basing that on an open source gateway or are you developing from scratch?
I will hold it and I will answer it a bit later, okay? I have to really run to stay on schedule. So what I also want to bring that we're also defining something different that, not necessarily considered in the DAOS open source domain, but we call it the fault domains on the configurations. So basically what it is, when you have a massive installations of several racks of the systems, you start thinking about that, how you can tolerate some network issues, some switch issues, some glitch on the fabrics. And so we came with a proposal that's basically a hardware layout where you identify the fault domain beyond the server level. So you may identify the fault domain as your, let's say the switch rack. And so assuming that all the nodes that belong to the certain switch, that they belong to one fault domain. And then in future, when the DAOS client will be doing the algorithm placement, it will take into account the fault domain, and basically it will spread the data across fault domains. So instead of spreading it across the servers, now you take the also understanding and topology awareness of a fault domain configuration. That doesn't exist today in the DAOS code, but as you heard, it's coming, and this is one of the areas where we're considering to be, how that could be implemented. But for us, in order to advertise it to customers and in order to start deploying a fees, we're already doing the hardware sizing and hardware configurations. So when somebody comes with some system that will be in production late 26 or in 27, we will take that into account. What in general the, let's call it value add of what HP brings in addition to the DAOS Foundation releases? Well, first of all, I want to highlight that we are not forking DAOS. So there is no two different branches of the DAOS between the DAOS Foundation and what HP releases as the code for the K3000 systems. So here the strategy is that we take the latest DAOS release as is, and we integrate it with our additional software stack. So that software stack mainly used, first of all, for the provisioning, system orchestration, telemetry. This is what's coming with the HP Cray cluster management tools. That's part of the, Cray history. So that's the tools which are managing the full cluster set across the all the compute nodes and so on. We are using the subset of these tools to manage storage only. So if customer who is not HP compute node and customer and not buying the compute cluster, still deploying our storage server, storage installation, it comes with its own provisioning and management tool. It doesn't need to be integrated into the overall cluster management, and it stays independently. So that's the advantage, and that's the need why we have this admin node, because what it's doing is down the whole level of the system provisioning. All the image creation, image deployment, and that's why we have the 10 gig management interface to every of the storage nodes. And so the admin node is doing the deployment through this, so that allows you to have a lot of bandwidth to make sure that you can provision all the systems. Systems coming from Chippewa Falls factory, fully provisioned. Of course, it's waiting for some of the user information, such as IP addresses, but it came fully ready. If we need to reprovision the systems for any reason, we can do that. Of course, the admin node will be doing all of that. So that's the advantage of the full HP integration. We are doing a lot of integration with the hardware. Of course, the hooks to the ILO, that's part of the ProLine servers. The API that we provide internally. And most importantly, we create our own, let's say, the control plane to the DAOS. So basically, we are using what DAOS provides, and we put the extra level that simplifies all of the control and the management configurations. So that's called Cray storage commands, so CSC in short. So when you'll be logging to the K3000 system, you see the CSC, and it's basically the front-end administration and the control of DAOS. You are absolutely able to use all the existing DAOS, like DMG, for the management, but with CSC, you'll do that much easier way. So, and of course, a lot of other things, including the full commercial support, including the full solution, installation, rackless installation. We do support POC. We have a special SKUs for the smaller installation systems. It doesn't need to be a rack scale. It can be a sub-rack. It can be a small installation. And our minimum install starts with the 4 nodes. Here's like a quick comparison between the what typically it takes to set up the system with DAOS versus what it takes to set up with the K3000 CSC control line. So it's not just scripts. I want you to understand that it's a whole suite of the provisioning telemetry and the monitoring that exists underneath. So, and it's just an example of the command line, how you do provision the whole system. Same way, the upgrades and updates are also simplified. So I just bring it as an example for you to see, not really to read in the commands, but to see how where we focus our intention and development in the first place. So what we do in the next release and what capabilities we see to continue to be developed as part of the HP offering. So here, of course, we will continue base our recent stack on the recent DAOS stack. So for this, while K3000 first release is based on DAOS 2.8, the next release will be based on the 3.0. So we are in cycle with the foundational releases, and we create our additional development increments to these releases, so we align our major releases. In between, of course, we have minor releases with all the bug fixes and other types of things. We are looking to continue expanding the whole administration tasks and how we visualize and make it simpler with operating the storage. At the current the first release, we don't have any specific GUI, but we have the dashboards and integration. These are Grafana-based, but these are newer release Grafana-based dashboards. So you still operate through a command line. We are seeing how we can change it later. We are working on of course, with different platform integrations, and here we have dependency on the metadata on SSD phase 2 that Joan was talking about, and this is why we are looking for the next higher density and higher capacity systems in the later releases, because it will be aligned to the DAOS 3.0, and so we don't need to have that much of a DRAM, and we can optimize the DRAM capacity per storage node for the very high dense installations. That's also a way for us to bring the higher capacity TLC SSDs and potentially QLC SSDs in the other coming releases. So that's where our focus is. And to close in this, Mike already introduced that in the morning session. Very happy with what happened originally with the Oak Ridge press release and announcement, and stay tuned for updates there. So, closing the session, I want to remind you that there are many other DAOS tracks are happening at the current time, so make a screenshot and make sure that you'll be able to join some others which are happening later the week, including, of course, is the IO500 BOF that will be on Thursday. Thank you very much.
Any other
Questions?
Yeah, thanks for all that great detail about the hardware details. I was curious, are all the NVMEs used in like a homogeneous way, or do you dedicate some for metadata and some for journal?
All NVMe used in a homogeneous way today. That helps us to spread the metadata across all the drives to get the maximum performance. This may change when we start considering the QLC installations, because then you may have some mixed configurations, and this is really, we need to define how we will do that from a topology perspective. But for today, for this first release based on the DL360's Gen 12, all 20 or 8 NVMe, no matter what's count, they all in a homogeneous way. I have to repeat that all the system configuration also have to stay in a homogeneous way. So if you started deploying with 8 NVMe per server, you have to continue that way if you want to continue expanding. Otherwise, if you want to expand the number of NVMe per server, you have to reformat the system.
Great, thank you.
Thank you.